Welcome to the Software Engineering channel on YouTube. Today we're going to continue our discussion of C++, introduce functions, lambdas, and functors. So what is a function? Well, so far we've seen examples of functions, but we haven't really gone too deep into what they are or why you would use them. The first function we saw is the actual entry point for any program in C++, which is the main function. Ideally, a function should perform a very specific task so that it allows you to organize your program logically. It's a subroutine, it accepts 0 or more typed parameters, and returns a value. A function that has no return value, or you don't care about the return value, would return void, but it's still a type. So why do we need functions? Well, again, it allows us to organize our code logically so we can separate tasks. It encourages code reuse so that we can test our new code efficiently, and allows us to reuse things repeatedly that we've already tested. So we know something works, we continue to use it. So how do we declare and use a function? Now, a function, as the question implies, must be declared. It also must be defined. A declaration says this is what the function will look like. In other words, it gives you the return value, a name of the function, and the argument list. Specifically, it may or may not include the actual names of the arguments. But it has to include the types. When it's defined, not only must the types for the arguments be defined, but also the names of the arguments. In addition, you'll also see the return value and the function name, which match the specified return value and function name that are in the declaration. Function arguments are the parameters you pass into a function. You can also pass in or give it default values when you declare a function. So if you want to have 3 parameters and the last parameter you want to say is an optional one and it has a default value, then you can do so. And we'll show you how to do that as well. And again, it must have a return value, so when the function gets to the end of it, or if you want to exit out early for whatever reason, you would return the appropriate value, depending on what type the function must return. So the parameters are passed one of 2 ways. They're either passed by value or passed by reference. By default, C++ will pass objects by value. When you pass by value, it actually copies the instance of the variable. So if I have an integer, it will copy that integer. If I have a string, it will copy that string. This can be expensive when you have large types, like strings or vectors, things like that. That's where pass by reference can come into play. Or if I just pass the reference, I'm only passing where the variable is. Now, the problem with that is if I pass it just by a naked reference, I could change the value inside the function, and that would influence what the value is outside the function. If you don't want that to happen, you would pass it by constant reference, meaning that it's still being passed by reference, but you can't change the value inside the function. The benefit of this is it avoids expensive copies. Real quickly, I'm going to introduce recursive functions. Recursive functions are functions that call themselves. To prevent this from having some major problems, specifically infinite loops, you must have a recursive case that converges, and it must have a base case. When you reach that base case, it will close out the function. So something like the Fibonacci sequence, when you get down to the very lowest point, it's going to exit the function, which would cause all the previous calls to also exit. If you don't do this, you'll end up with a form of an infinite loop called infinite recursion, which actually can crash the program much faster than an infinite loop, because when a function is called, it creates a new call stack, and when you create too many of those, you end up blowing up the memory stack for the program, and very quickly can end up in a situation where the program just crashes. In C++, you can overload functions. This means that you can declare a function that has the same name and same return type, but has different parameters. The reason for this will allow you to have names that do similar things for different operations. Say, and the example we'll show here later is if you want to calculate the area for a circle and then you want to calculate it for a cylinder or a square, you could have different return types, or sorry, different parameters, not return types, same return type, different parameters for those, and it would still be the same function name. So functors and lambdas I'm going to introduce here, even though it's a little more advanced. A functor is a class or a struct, and we'll introduce those in the next lecture. That the operator parentheses is overloaded, so the instance of that class or struct can behave like a function. This will allow you to do a bunch of different things that we'll see later on, but I want you to know about them now. And also, the reason that lambdas were introduced is because you don't want a bunch of single-use classes lying around, which is what a functor would be if you only need to use it in one place. It can be really annoying to maintain, can clutter your namespace. So C++ added the ability to create lambda functions. And these are anonymous functions that can take the place of many functors. And we'll show some examples of those as well. So, and with that, let's jump into the examples. The first example we're going to look at is a function example. We're going to go into more details on this. So here I've included a couple of the standard library headers. I won't go into too many details about these. The IOStream one we've already been introduced to, which allows us to do input-output via the console. Algorithm and limits are needed for a couple of the error checking instances that I'm going to go into here down the road. So here I'm just going to go ahead and declare a constant, label it pi, and I'm going to declare that there's a function called area that returns a double and accepts a double. Now notice that I could also declare the function just like this without giving the parameter a name at this point. When I implement the function, it will need a name, but it doesn't necessarily need it at the declaration. It just needs to know the type. So here I have main. I'm creating a temporary or a local variable called radius. I'm going to ask the user to input the circle radius. Here I'm going to go ahead and show you some error checking that you would do typically for console input. So here I'm going to, you start a loop when I'm checking the state of the stream after I ask for the user input. So I'm expecting to pull any sort of number from the stream. So anything that can be converted to a double, so an integer or a double. And I'm expecting to pull that in the stream. If it's unable to do that, say that I put a letter in the stream instead, then the stream goes into an error state. When that happens, this will return, this block that I have highlighted here will return false. So I want to make sure that I not that so that I can jump into the loop. That means that I entered a bad state. So this not true would be false. If I entered a bad state, I'm going to tell the user, hey, correct that, enter a valid number. I'm going to call clear, which will clear the error state of the stream, and then I'm going to clear all the junk that might still be on the stream. Because if I didn't call ignore, it would just go into an infinite loop here, constantly trying to pull the same information that I just entered. Here, I just ignore all the junk that I just entered and ask the user for more input. So then it'll come back around and repeat. Think, all right, now let's try again. Once I get valid input, this loop will exit. And then I can call my function. Note that at this point, I have not implemented it. I've only declared it. So if I were to compile it, at just this point, it would compile successfully, but it would not link correctly. So then I'm assuming I get the answer and I output it in the program. Here, this is the implementation. So if I commented this out, and we'll go ahead and show what that looks like so you can be familiar with the error code. So I come in here. Note that it compiles correctly. But it's going to tell me, hey, you have an undefined reference to the function that you declared. All right. So, oops, I need to declare it. recompile. Now it links correctly. Right, so now I can enter the radius circle. Now if I enter something junk, notice that it says, hey, dummy, enter a valid number. Okay, well, let's enter a valid number. And you get the calculation for the area. Now, as I mentioned, you can overload functions. So let's say I come up here. This would allow me to calculate the radius of a cylinder. Just for the sake of saving some typing here. So now, notice that these functions are named the same, but they do completely different things. Similar, but different. Now also note that I could do this if I wanted to. This way, which would probably be better because it encourages the code reuse, so I don't have to redo this. So we'll go ahead and do this. Oops. I should probably ask for height. Yes, technically this is not area, this actually would be volume, but just for the simplicity of the example here. Alright, so now let's and we get what we expect. So that's a quick rundown of functions. Now let's jump over to functors. And actually, I'm not going to do functors. Let's do lambdas. All right, so here we're going to do a simple example for lambdas. I'll do a very a more comprehensive example later on. This I just want to introduce you to the power that you can get with these functions. So here I'm including the algorithm library, which again we'll go over much later, but we need it to kind of demonstrate this. And I'm going to create an array of, let's say, the first 10 integers of the Fibonacci sequence. I'm hard coding this just for this demonstration. Again, this is much more powerful, and we'll get into more details on it later on when we get to data structures and algorithms. This is meant to be a very quick introduction to Lambda functions. So here I'm just going to print out that, and then I'm going to use a for each call. This is a function that's provided in the algorithm library that will run a loop from the beginning to the end, and it will call this function. So you could put a functor or another function name that, as long as this function takes an integer parameter, it will, because this is what I'm passing in with the integer, or anything that can be converted to an integer, or an integer can be converted to, rather, it will operate correctly. And then in this particular case, the lambda that I chose is just going to print out the single line. You can see, instead of having to write my own loop, I can use this for each call, and it would do the same thing without having to worry about getting my loop parameters correctly and whatnot. It does all the work for me. So just to demonstrate this, here it says the first 10 Fibonacci numbers are, and then it prints them out, which is the exact same numbers that were in this list. As you can see, this right here is known as what is called the capture. Again, we'll get into more details on this later. What this means is how different elements outside of this scope, this function call, can be treated. Right now I'm not passing anything into capture. It's just going to deal with whatever is passed into the function, which is just this integer, and then I create this anonymous function in the scope here. And as you can see, it does exactly that when I output it on there. This can be a very valuable tool later on, where you don't have to create one-off functions or one-off functors to do what you want. You can use lambdas instead. So with that concludes our introduction to functions, functors, and lambdas. Our next lecture, we will get into classes and structs, and possibly even introduce makefiles, since we'll be dealing with multiple compilation units at that point in time. So with that, have a great one, and see you next time.